What's going on, my math people? We're back again, and we talking about these derivatives. All right, so first of all, before we start talking about anything, all right, let's go ahead and point out something right quick, right? We're talking about derivatives as a function. All right, this guy, boom, that is not a 1, okay? That is called prime, all right? Like Optimus Prime or whatever. Anyways, this says f prime of x. So that's meaning the first derivative of the function f. All right, so we needed to clear that up right quick. So don't think that's a 1 or a tally mark or any of that fine stuff. All right, let's ease on into some work though. All right, so jumping straight into it, we got to go to these examples, man, because that's what we want. We want the word because these examples can get crazy. All right. So let me get me some black right here, and let's toss in this crazy example right quick. Let's say you want to find or differentiate, find f prime, find f prime for the function f of x equal 5x plus 4 over x at x equal 3. Wow. Okay, we about to do some stuff. We ain't never scared. Nah, we about to do it. We jumping straight in. So notice, we pretty much abused this definition of a derivative. All right, this slope right here. So you already know we got to go ahead and toss that up in there. All right, so we're gonna go ahead and find f prime of x using that definition up top. Boom. So we have the limit as h goes to 0 of x plus h. So we have 5 times x plus h plus 4 over x plus h. Oh my, that got real funky real quick. Okay, minus. All right, open up your parentheses, keep yourself safe. 5x plus 4 over x. All right, so and that's all over h. Man, that jumped crazy real fast. All right, so we got to go through some simplification. Equals the limit as h goes to 0 of 5x plus 5h plus 4 over x plus h minus 5x minus 4 over x all over h. All right, go ahead, clean house right quick. That 5x, it got to go because it's deducting against itself. And let's see what we have left over up there. What we have left over, we have the limit as h goes to 0 for 5h plus 4 over x plus h minus 4 over x all over h. All right, still looking pretty crazy. So we're gonna do some stuff. We got to get that common denominator for the top. All right, we need a common denominator for that piece. And so we have the limit as h goes to 0 and common denominator trick. Take all those denominators. The denominator of 5h is 1. Denominator of the second term is x plus h. And the denominator of the final term is x. Denominator trick. Boom. Run it straight across. You got 5h plus and 5h didn't have the x plus h times x, so you're gonna put it beside it. Boom. Plus 4. 4 didn't have the 1 and the x, so we're gonna put that there. Minus, well, negative 4 did not have the 1 and the x plus h, so we're gonna add that there. Quick denominator hack. You're welcome. All right, so we're gonna run that clean cross and keep it rolling. Going through simplifying, we have the limit as h goes to 0. Simplifying the denominator, we have 5x squared h plus 5xh squared plus 4x minus 4x minus 4h all over. You see these two denominators? They multiply against each other. We're running you all the way back to your middle school, multiplying rationals. So we're just going to go ahead and write that as h times x plus h times x, so we don't have all these stacks. Boom, I see some more simplification action that need to take place. That 4x got to go because it's deducting against itself. All right, bringing us back, we have the limit as h goes to 0 of 5x squared h plus 5xh squared minus 4h all over h times x plus h times x. Numerator, factor in h out of everyone. When we factor out h out of everyone, that leaves us with h times 5x squared plus 5xh minus 4 all over h times x plus h times x. Look at there. Look what kind of action we have. We have, boom, that goes to 1. So that's 1 times all of that stuff. That's identity element. Now let's go ahead and start rushing this h to 0 because we've simplified as further as we can go. So we're going to go ahead and plug in that 0. That leaves us with 5x squared plus 5 times x times 0 minus 4 all over x plus 0 times x equals 5x squared minus 4 all over x squared. The problem says it wanted you to find the slope at x equals 3. So we're going to go ahead and slide that value of 3 in here. We have 5 times 3 squared minus 4 over 3 squared equals 45 minus 4. That's 41 over 9. Your slope at x equals 3 is 41 over 9. All right? And that's every example finding derivative as a function. You're applying that definition. You're straight up applying it. So with that being said, verify the work, go through the simplification. Hey, jump on it, make it happen. Until next time.